So here's another force diagram problem and interaction diagram problem that we need to solve. The one difference here is that we're going to need what's called a component diagram. So let's start off with the interaction diagram. So I've got a person, and they're also on skis. Not sure, 100% sure I spelled that right. There's the Earth, and the assumption we're going to make there is we're also on the Earth's surface. Okay. So in other words, we're combining the Earth and the Earth's surface in the one object. In the other object, we're combining the person and the person's skis. There's also a rope in this system. We could also include the boat, but that won't be necessary in this particular system. So between the person and the rope, we have the force of tension. So let me draw that in. So F sub t between the Earth and on the Earth's surface and the skis, we've got the normal force. Between the person and the Earth, we've got the force due to gravity. I'm going to do dotted lines here. Because the force due to gravity is a non-contact force. Between the rope and the Earth, we also have a force due to gravity. Okay, and so this is my system. And outside of my system is the environment. For example, we can include the boat out here if we want and draw lines into our objects inside the system, but we're not going to do that quite yet. So again, the assumption here that we're making is that the skier is moving with constant velocity. So let's go ahead and draw a horizontal motion map. So in the horizontal, we're used to drawing this already. We've got the position line to the right is positive. The object or the skier is moving with constant velocity. And the acceleration horizontally is going to be 0 because there's no change in velocity. That's a definition of acceleration. In the vertical, we know the object isn't moving at all in the vertical, so we'd have a dot for velocity, a dot for acceleration in the vertical. So because it's moving with constant velocity, so the assumption here, we're moving with constant velocity, we've got to make some very important distinctions here. So let's draw our force diagram. So in this force diagram, I'm going to first draw the horizontal and vertical components, and I got to draw them in the correct direction. So to the right, I'm going to draw the force of tension, and that's on the person by the rope. We've got the force due to gravity, on the person by the entire Earth, and we also have the force due of the normal force on the skis, but we put the skis and the person together by the surface. Okay, so that's our force diagram. So now let's draw the force diagram with components. So this is something that's a little new. We draw force diagrams with components whenever any of our forces are not on the vertical or horizontal axis. So this is on the horizontal axis, so it's good. This is on the vertical axis, so it's good. but this one is not on any axis. So that one's going to need what we call the horizontal and vertical component. So you're required to always redraw the force diagram exactly like it is before we do our component diagram. So we call this the component diagram. Okay, so we basically redraw everything. The force diagram, the normal force with the person or the surface on the person, the force of tension on the person by the rope, and the force due to gravity on the person by the entire earth. So again, it's this force that we need to be concerned about, the normal force. So we're going to draw its horizontal and vertical components. So its horizontal component goes along the x-axis like this, okay? And we call that the normal force in the parallel direction. By parallel, we say parallel to surface. And then we'll have another force that's in the vertical, so it has to complete this right triangle here. So this is a right triangle right here. And my vertical force, I'm going to say, is the normal force in the perpendicular direction. So that's perpendicular to the surface. So now what we've got to do is we've got to make sure to look at our what is equivalent, or what forces are equivalent. So here what we've got is we've got this force, this normal force, and this force of tension. These two forces have to be equivalent in the horizontal direction in order for there to be no acceleration, okay? And then we will also look at these two forces, the normal perpendicular force and the force due to gravity. They've got to be equivalent in order for this motion map to show that there's no acceleration. So that's this is, to wrap that up, this is our motion map. This is our motion map. This is our component diagram. This is our force diagram. This is our interaction diagram. You always have to draw the interaction diagram, the motion map, and the force diagram. We only draw the component diagram if there are any off-axis forces. For example, in this case, the normal force that the surface applies on the person.